Hello and welcome to Geometry. In this section, we're going to be looking at Chapter 17, Section 2, Measuring Arc Length. Arc length is just a chunk of the circumference. So here in the warm-up, we're going to find a full circumference. We've got a couple formulas to choose from. Here in the picture, they do give us the 12 meters, looks like the full diameter. So I would tend toward this one in red. We could do circumference equals pi times diameter 12. If we went with the blue one, we would have circumference equals 2 times pi, and the radius would be half of this, so that would be 6. And as soon as I multiply this 2 by this 6, I get my 12 times pi. So we could say 12 pi is the circumference. That is the exact value. But if we use the pi button on the calculator, we would get this as about 37.699 meters, or maybe about 37.7 meters. And now if we want to find the area, area equals pi times radius squared. Our radius would be 6. 6 squared is 36. So our area would be 36 pi square units. And if we use the pi button on our calculator, the area is about 113.097 meters squared. So again, what we found here is the full area and the full circumference. Today we're going to find arc length, which is just a fraction of that full circumference. So a little fill in the blank. An arc is an unbroken part of a circle consisting of 2 points called the endpoints, and all the points on the circle between those endpoints. The distance along the arc, measured in some linear units like centimeters or meters or miles, is called the arc length. You can apply the fact that there are 360 degrees in a full circle to find the length of the arc. So let's look here in the first box. Our circumference formula, let's use 2 times pi times the radius, and our radius here is 10. So 2 times 10 is 20, or 20 pi. As a decimal, that would be approximately 62.8. All right, now let's look at the arc AB. Here's the arc AB in red. How many degrees is arc AB? Well, our central angle has that little mark in there, that little box. So that's a right angle, or 90 degrees. So as a fraction of a full circle, this is 90 degrees. Out of a full 360, there's our fraction. And in this case, it can be reduced down nicely to 1/4. So if I want to find just the length of this red arc from A to B, I'm going to take the circumference, 20 pi, and I'm going to multiply that by the fraction 1/4. 1/4 of 20 is 5, so 5 pi. 5 times pi is about 15.7 units, whatever units they're going to give us. So again, the full circumference would be 20 pi. We don't want the full circumference. We just want this fraction of the circle. So we would do the full 20 pi times our fraction 1/4. All right, below we got something similar going on. Circumference is 2 times pi times radius 7. So we have exactly 14 pi units there, or as a decimal, about 43.98. Now let's see, arc AB here is half a circle, because A to B looks like a radius. So the arc would be a 180 degree arc, and 180 degrees out of a full 360 reduces down to a half. So this arc right here that I'm hitting in blue ink is half of our full circumference. So we're going to do our 1/2 times the full circumference, 14 pi. That's 7 pi. As a decimal, that's about 21.99. Oops. 21.99 units. Okay, and that takes us to our definition here of arc length. The arc length S of an arc with measure x degrees. Here in our picture, this x degrees is our measured red arc here from A to B. And the radius is given as r. We use this formula. S is arc length. The x over 360 is our fraction of a circle. Oh, my pad's glitching here. Fraction of a circle. Fraction of circle. And the 2 pi r is the full circumference. So we're multiplying the full circumference by some fraction to get that length of the arc. All right, example 2. Find the length of AB. Well, AB is marked here. They give it to us as 60 degrees. So S is arc length. 60 degrees is our arc out of a full 360-degree circle. And we're going to multiply that by 2 times pi times 12. So on your calculator, you could do 60 divided by 36 equals times 2 times pi times 12. And you should get 4 pi, or approximately 12.57 units. All right, example 3, pretty much the same. Different radius, different arc. So S, arc length, is 120 out of the full 360. And we're going to multiply that fraction by 2 times pi times 9. 2 times 9 is 18, so we have 18 pi. 120 over 36 reduces down to a third. A third of 18 is 6 pi. 6 times pi is about 18.85 units. All right, that was easy. Example 4. Now this is a little different. We're specifically dealing with a clock here. So the Palace at Westminster in London, England, has a tower with a circular clock face set in an iron frame. The clock face has a diameter of 23 feet. The tip of the minute hand sweeps across the iron frame as time goes by. How far does the tip of the minute hand travel as the clock goes from 10:05 to 10:25? Now we know we usually do x over 360 is our fraction of a circle. Well, when we're talking about a time and the minute hand goes around, every time it goes around is 1 hour or 60 minutes. And if we go from 10:05 to 10:25, it's traveled 20 minutes. So 20 out of 60, that will reduce down to a third. That is our fraction of the circle. So our S, arc length, is going to be 1/3 of the full circumference. And since they gave us the diameter of 23 feet, let's just do diameter times pi. So 1/3 of 23 pi, we could just calculator do 23 times pi divided by 3. Our arc length is about 24.1 feet. All right, short lesson today. That's the last example. So here's the practice problem. Pause the video, give these a try. If you're going to have any trouble, it's probably setting up number 4 and number 5. So have fun and start the video back up when you need it.
Show me what you got.
All right, number 1, A is not bad. So our arc length for a 135-degree arc out of a full 360-degree circle times 2 times pi times the radius 5. Yeah, so that'll be 10 pi times our fraction. And we should get S is about 2.36. In this case, wrong. Back. That should be 11.78. Arc length is approximately 11.781. We do have units now, so we can put an M on there for meters. Letter B, pretty much the same. Arc length is now an 80-degree out of a full 360 times 2 times pi times radius 5. Calculator tells me that's going to be about 6.98. Once again, units are meters. All right, number 2, we've got ABC. Find the length of arc AB to the nearest hundredth. So our arc here is 45 out of the full 360, 2 times pi times radius 3. So 45 out of 360, that actually reduces to an eighth. An eighth of 6 pi would be 3/4 pi, or as a decimal, about 2.36. Our units are inches. All right, in letter B here, arc length is going to be 160 out of a full 360 times 2 times pi times 8. Calculator tells me that is about 22.34. Units now are centimeters. All right, letter C. S for arc length is 80 out of a full 360 times 2 times pi times 6. So that'll be 2/9 times 12 pi, or about 8.38. Now our units are feet. There we go. Okay, now number 3, we have a metronome. Provide tempo for musicians by producing clicks at a set interval. Each swing of the inverted pendulum produces a click. Each swing, it goes out a 70-degree arc. So we're not looking at a full circle here, but we've got our slice, and we know our central angle is 70 degrees. So the arc length of this edge would also be 70 degrees. It has a radius of 18 centimeters. What distance does the tip of the pendulum travel on each swing? Round it to the nearest centimeter. So S, arc length, is going to be 70 out of the full 360 times 2 times pi times radius 18. That goes in the calculator, and I get the output of 21.99. Rounded to the nearest centimeter, let's just make it 22 centimeters. Okay, enough of the fun stuff. Let's do the tricky stuff like this. Picture here was pretty terrible. I drew my own rendition of it here. Concentric circles. I'm going to do in red arc AB, and I'm going to do in blue arc CD. So let's read our setup. 2 concentric circles on a pocket watch are shown. The length of AB is 3. I'm not even going to write it in there. I'm going to use red ink. 3.87 is arc AB. And back in blue, arc CD is 6.9. P to A is right here. P to A is 1.85 centimeters. Find the length P to D. So what we're looking for here is the radius of the bigger circle. So this find the length of PD is R of big circle. Round to the nearest hundredth. All right. So let's work on the inner circle first. And I'm going to do it like this. The arc AB is equal to some fraction, x degrees out of 360, times 2 times pi times the radius. Well, in this case, we're usually finding AB, but now AB is given as 3.87. My pen just glitched. There it is. 3.87 is equal to x over 360. X over 360 times 2 times pi times 1.85. We want to solve for x. So if we want to get x alone, first I would get this term alone by dividing by this stuff. So over here on the left, we're going to have 3.87 divided by 2 and by pi and by 1.85. And that's going to equal x over 360. And to get x alone, I'm going to multiply both sides by 360. So this numerator, what we could do is 3.87 times 360. That's your numerator. And then we're going to divide that by 2 and pi and 1.85. And that's going to be our angle x. That's actually going to give us our central angle in here, x degrees. If everything goes right on the picture, now the picture, of course, is not to scale because my calculator told me x is about 119.857. Now you're probably thinking, can't we round that to 120? I like to round at the very end. Here we're in the thick of this problem. We're in the middle, so I personally wouldn't round yet. So again, this is all the stuff in our smaller center inside circle. Now, I'm going to do sort of the same setup as I did there, but now we're going to do arc CD is equal to some fraction x over 360 times 2 times pi times a radius. Now CD is given. It's right here at 6.9. X, we found x. That's our 119.857 over 360 times 2 times pi times 2 times pi. Now r is our last unknown. The r of the bigger circle, I'm going to hit it here in black ink, that is PD, and that's what we're trying to find. Find the length of PD to the nearest hundredth. So here in this equation, we got numbers, 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 2 pi. R is our last unknown. So a quick way to do this on the calculator, I'm going to divide by 2 pi. So now my 2 pi is under my 6.9. I'm going to rewrite it down here. 6.9 divided by 2 pi. And now I want to divide by this fraction or multiply by its reciprocal. So what I could do is bring it down here and just multiply and flip it over. 360 over 119.857 times 6.9 over 2 pi is equal to our radius. If all goes well, you should have found the radius was about 3.30 centimeters. All right, that was a tricky one. I hope you got it. Number 5 is kind of tricky, but not quite as bad. Belt drives transmit power between a drive shaft and equipment. In the belt drive shown, the smaller pulley here is being driven by a power source and delivers power to a larger pulley through the belt. So the belt spins the larger pulley. The difference in size is used to change the speed at which that larger pulley will turn. Each full turn of the smaller pulley, through what angle does the larger pulley, for each full turn of the small pulley, what angle does the larger pulley turn round to the nearest tenth? All right, so let's do this. I could just write the small circumference is equal to the large circumference, but it's going to be multiplied by some fraction, x over 360. So small circumference is the same as the larger circumference, but we got to knock it down by some fraction. So let's focus on the small circle. The circumference there is 2 times pi times radius 5. So that would be 10 pi, or about 31.4159 centimeters. So there's our small circumference. Now let's do the large circumference. That's going to be 2 times pi times 12. 2 times 12 is 24, so it's 24 pi's. And then we can get that as a decimal, 75.3982. So just like I have up here, we're going to set them equal. I'm going to set 31.41 4159 is equal to some fraction, x over 360, times our 75.3982. And we just want to get x by itself. So what I'm going to do is divide both sides by the 75.3982. So this has now been divided out. And then to get x alone, I'm going to multiply that after I divide it times 360. If all goes well, x should be about 150 degrees. So as the small one turns a full rotation, the larger one will only turn 150 degrees. That's less than half. So this one goes around once. This bigger one will turn about 150 degrees. All right, that's the end of the video. I hope you found it helpful.